Myself K. Pravalika. My dish number 212H1A3072. Now I am discussing about the machine learning. What is machine learning and why should you care about it? Machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. The definition of machine learning coined by Arthur Simmel is often quoted as a genius in its broadness, but it used with a question of how the computer learns. To achieve machine learning, excepts develop general purpose algorithms that can be used on large classes of learning problems. When you want to solve a specific task, we only need to feed the algorithm more specific data. In a way, you are programming by example. In most cases, a computer will use data as a source of information and compare its output to a desired output and then correct it for it. The more data or experience the computer gets, the better it becomes as a designed job, like a human does. When machine learning is seen as a process, the following definition is insightful. Machine learning is the process by which computer can work more accurately as it collects and learns from the data is given. For example, as a user writes more text messages on a phone, the phone learns more about the messages, common vocabulary, and can predict, autocomplete their words faster and more accurately. In the broader field of science, machine learning is a subfield of artificial intelligence and is closely related to applied mathematics and statistics. All that might sound a bit abstract, but machine learning has many applications in everyday life. Applications for machine learning in data science, regression and classification of primary importance. Today, data scientists. To achieve these goals, one of the main tools a data scientist uses in machine learning. The uses for regression and automatic classification as wide-ranging, such as the following. First, finding oil fields, gold mines, or archaeology sites based on existing sites, classification regression. Second one, finding place names or person in text, classification. Third one, identifying people based on pictures or voice recording, classification. Fourth one, recognizing birds based on their whistle, classification. Identifying profitable customers, regression and classification. Protectively identifying car parts that are likely to fail, regression. Identifying tumors and diseases, classification. Predicting the amount of money a person will spend on product X, regression. Predicting the number of eruptions of a volcanic in a period, regression. Predicting your company yearly revenue, regression. Predicting which team will win the Champion League in social, classification. Occasionally, data scientists build a model, an abstract of reality that provides insight to the underlying process of phenomena. When the goal of a model is not prediction but interpretation, it's called root cause analysis. Here are few examples. Understanding and optimizing a business process, such as determining which products add value to a product line. Discovering what causes diabetes. Determining the causes of traffic jams. The list of machine learning applications can only be seen as a app teaser because its units within data science. Regression and classification are two important techniques, but the reported and the applications don't end with clustering as one other example of a valuable technique. Machine learning techniques can be used throughout the data science process, as we will in the next section. The modeling process. The modeling phase consists of 4 steps: features engineering and model section, training the model validation section, applying the trained model to unseen data. Before you find a good model, you will be probable by iterating among the first 3 steps. The last step is not always present because sometimes the goal is not prediction but explanation. Root cause analysis. For instance, we might want to find out the causes of species extinctions but not accurately predict which one is next to line our planet. It is possible to chain or combine multiple techniques. When you chain multiple models, the output of the first model becomes an input for the second model. When you combine multiple models, we train them independently and combine their results. This last technique is also known as ensemble learning. A model consists of constructions, information called features or predictors, and a target or response variable. Your model's goals to predict the target variable, for example, tomorrow's high temperature. Thank you.